If I use a wrench that is 8 inches long, then I can plug it in and find my ideal mechanical advantage. So 2 times pi times 8 inches divided by 1/20th of an inch. And that's going to be approximately 1,000. So you can see that this is a very large ideal mechanical advantage compared to the other simple machines we've been working with. To find my AMA for a simple machine screw, it's again the same formula you've been using before. AMA equals force resistance over force effort. So it tells me here that my force resistance, we're assuming it's whatever it's being screwed into, it's the resistance of that material, is going to be 1,200 pounds. So I'd put that on top. And then my force effort is 35. So 1,200 divided by 35 equals 34. So now in this example, when using an 8-inch wrench and 35 pounds of input force resulted in 1,200 pounds of output force, what is your efficiency? Because it's a screw, I'm expecting it to be pretty low. My efficiency is AMA divided by IMA times 100. So 34 divided by 1,000 times 100 is going to be 3.4%. Not all screw efficiencies are going to be quite this low, but they are going to be lower than the percent efficiencies that you've been getting for your other simple machines. Alright, so now I think we're ready to go see what I found in the garage. Alright, now I have a screw to show you. Alright, so here is a screw. I tried to find a larger screw so that we could easily measure it. Alright, so we're going to look at this section here. I've kind of darkened it so that you can see it better. So first, the distance of our resistance is going to be from one thread to the next. Because when this rotates, an entire rotation revolves around one time, then it's going to go into whatever you're trying to screw it into. It's going to go down this distance, one rotation. So let's go ahead and measure that. Right. And sometimes it's easier to go from like just 1 inch in the middle of your ruler because sometimes you lose some here at the end. So looking here, you can tell that it's 1/8 of an inch between the two. Or if you're given a full inch, how many is that? We're going to count. 1, 2, 3, 4, 5, 6, 7, 8. So you can tell that there are 8 threads in an inch. And just by looking at it too, we could tell that it was 1/8 of an inch distance that it's going to go down. Alright, so whenever we hook this to a tool, let's use this one here. I tried to find one with a really good mechanical advantage. We need to find the circumference because whenever I am putting a screw into, say, wood or whatever it is that the medium that I'm putting it into, one full rotation, my effort, is going to be the circumference of this circle. So to find circumference, it is just going to be 2 times the radius times pi. So we need to find that radius. So the radius is going to be from my center point here, to where my effort is going to be. So my effort is going to be on the handle here. I'm going to go to the outside of this handle. The outside of the handle is about right here. So that is 5.5 inches. So the radius is going to be 5.5 inches. So to find the circumference, which is the actual distance that my effort is actually traveling, okay, so the effort, I start here, go all the way around, that is the circumference. And that would be my distance effort. Alright, now let's use those values to find the IMA of that screw and wrench combo. So my IMA equals distance effort over distance resistance. My distance effort was 2 times 2.5 inches, and my distance resistance is 1/8 of an inch, which equals 15.7 inches over 0.125 inches. When you take 15.7 inches divided by 0.125, you get 125.6 as your IMA. And of course your inches are going to cancel out. This is a very high IMA. You'll find that your screws will have very high IMAs, but most of the time the AMAs will not be quite as high.